Good morning, students. So we have doing the continuous time Markov chain. So share the screen. Okay. So last time we have done the Kolmogorov backward equation. So now let us now start with the Kolmogorov forward equation. Okay. So Kolmogorov under suitable regularity condition. Pij prime t, that is derivative of this, is summation k is not equal to j, qkj pikt minus vj pijt. This is 2. So let us see the solution of this. So let us start with pij t plus h minus pijt. Now using Chapman-Kolmogorov equations. These are Chapman-Kolmogorov equations. Using this, we can write down easily. This is summation. K is from 0 to infinity. P I K T P K J H minus P I J T using Chapman-Kolmogorov equations. Now take out the ith term from here. Jth term, let us take. K is not equal to j. P I K T P K J H minus. So the term will come outside is this minus 1 is this, and other term will be in plus. Jth term from here basically. So that is P I J H we can take, and P J J H P I J T. Okay, so this is the term we are getting. We take out the jth term from one, put in the other. Now we take limit as h goes to 0, Pij t plus h minus Pij t upon h. So divide this term by h and take limit as h goes to 0. What we will get? We will get, this is limit h goes to 0, summation k is not equal to j, p k j h upon h p I k t from the first term and minus 1 minus p j j h upon h p I j t Okay, so this is the term we are getting. Now, this implies that this is P I j prime t is, take limit, and from the lemma we can easily see that this is qkj. So this you can see from this lemma, this lemma star. Okay, so this pij upon h is qij, and 1 minus pih upon h is vi. So from this lemma star, so this is summation k is not equal to j, qkj pikt minus, and this term is vj piJt okay. So this is nothing but this is using lemma star. So but this is the result we want to show. This is Pijt is summation k is not equal to j, qkj pikt minus vj pijt. So this is the Kolmogov forward equation. So let us see example for forward equation for birth and death process. So we know that in the backward equation we have already derived for birth and death process. These are the various parameters. Okay, so these are the parameters basically. So same parameters we will write. So this, let us say, using, so you can see in double star. So here qii plus 1 is lambda I, qii minus 1 is mu I, other values are 0, and v naught is lambda naught, vi is lambda I plus mu I, other values are 0. So therefore from the forward equation, this is the forward equation. Now Pij prime t is we have q. Let us take first of all k as j minus 1. So we will have q j minus 1 comma j. So that will be lambda j minus 1 from here, q j minus 1 comma j p I comma j minus 1 t, then plus, let us take k as j plus 1. So q j plus 1 comma j is mu j plus 1, and p I comma j plus 1 t, and vj is nothing but lambda j plus mu j for birth and death process, pij t. So this is the value we are getting for Pij prime t, and this is using the forward equation. So now using forward equations, so what is our value for Pi 0 prime t? So we are taking j as 0. So q 1 we can take 1 0. 1 0 will be mu1 and p I1 t and v naught will be lambda naught. Lambda naught p I0 t. So this is the equations we have for uh, birth and death process. So any question till now?
No, sir.
Okay. Now we are finding out the, as we have done for the discrete time Markov chain, we are finding out the limiting probabilities, which is also known as the steady state probabilities. So here also we are finding out the limiting probabilities. Or steady state probabilities. So the probabilities that continuous time Markov chain will be in state J at time t often converges to limiting value which is independent of the initial state. Okay, so probability that a continuous time Markov chain will be in state J at time t often converges to a limiting value which is independent of the initial state, that is Pj, or we can say pi j, whatever you denote, is limit Pij t goes to infinity. So when t goes to infinity, this often, not always, often converges to some particular value Pj, which depends on the final state only J. Okay, so let us assume that this happens. So then the limit, these are the limiting probabilities. So how to find out? So we know that from the forward equation, P I prime t is summation k is not equal to j, qkj pikt minus vj pij So take limit as t goes to infinity, Pij prime t. This is limit of this limit t goes to infinity. Now summation k is not equal to j, qkj pikt minus vj pij t. Or when the limit will go inside, then because we know that these probabilities will basically depends on the final one. So this will become pkt. So this will be summation k is not equal to j, qkj pk minus vj pj. So this is the value we are getting in the uh, limiting probabilities case. So now, however, we know that Pijt is bounded function. Probabilities are between 0 to 1. Also, Pij t is converging to Pj as t goes to infinity. So therefore, derivative of this will converge to 0 as t goes to infinity. So therefore, we will get 0 is equal to summation qkj pk minus vj pj. K is not equal to j. So this implies that vj pj is summation k is not equal to j, q kj pk for all states j, and summation pj summation over j is 1. So, so this is used to solve, these two equations are used to solve limiting probabilities or steady state probabilities. So now we have assumed that the limiting probability exists. A sufficient condition is that all states of the Markov chain communicate, in the sense that starting in state I, there is a positive probability of ever being in state J for all I and J. And Markov chain is positive recurrent, in the sense that starting in any state, mean time to return to that state is finite. So if these holds, then limiting probability will exist. And Pj is the long run proportion of time that the process is in state J. So let us say, take an example. So limiting probability is basically we are assuming that positive recurrent states are there and all states communicate basically, then the limiting probability exists. For birth and death process, so we know that for birth and death process, uh, we have a state. So we n and 0. So Vn Pn is summation k is not equal to j, q kj pk. So these are the values n and 0. So Vn Pn. So this basically this equation is coming from the forward equation. So forward equation basically we have solved already. Pijt basically will converge towards 0. So and pi and your pi and limit t goes to infinity, pi comma j minus 1 is pj minus 1. Okay, and pi comma j plus 1 will be p comma t will be pj plus 1, and this value will be pj. Okay, so therefore from here we will get easily get that this will be lambda n plus mu n pn is mu n plus 1 pn plus 1 plus lambda n minus 1 pn minus 1. From where we are getting, because forward equation are these, just limiting value we are taking. So from this equation we will get the answer. Okay, so this, and also from the second equation we will get lambda naught p naught is lambda naught p naught is equal to mu 1 p1. So that is the answer we are getting from the second equation from state 0. So therefore this will be lambda naught p naught is mu 1 p1. So therefore this implies that p1 is lambda naught upon mu 1 p naught, and p2 is And from this equation, when we take our n is equal to 1, we will get lambda 1 plus mu 1 p1 is equal to mu 2 p2 plus lambda naught p naught. But lambda naught p naught is same as that of mu 1 p1, so therefore this will cancel out. So this will imply that p2 is equal to lambda 1 upon mu 2 p1. So but p1 is lambda naught p naught, therefore this is lambda naught lambda 1 upon mu 1 mu 2 p naught. Okay, so in the same fashion, so on, we will get pn is equal to lambda naught lambda 1 into lambda n minus 1 upon mu 1 mu 2 mu n p naught, which is cn p naught, where cn is lambda naught lambda 1 lambda n minus 1 upon mu 1 mu 2 mu n. So pn is equal to cn p naught. Also we know that summation pn n is from 0 to infinity is 1. This implies that from here 1 plus, we are taking p naught common, c1, because our p1 will be c1 p naught plus c2 plus so on, p naught is 1 because our p naught plus p1 is c1 p naught, taking p naught common, then p2 is c2 p naught, taking p naught common, and in the same fashion this is this. So therefore this is s times p naught is 1, where s is 1 plus c1 plus c2 plus so on. So therefore this implies that p naught is 1 by s. So therefore p naught is 1 by s here. So a necessary condition for these limiting probability to exist is necessary condition for these limiting probabilities to exist is that this S should converge. Okay, that means that should be finite, then this probability will exist basically. So therefore this is the necessary condition for existence of the limiting probability. So let us take this is U. Any question till now? Okay, so am I audible to you now?
Yes, sir.
Okay, okay, okay. So let us take some example when the limiting probability will exist. So let us take example. So let us take MMS queuing system. That means inter-arrival times are exponential. That means the arrival is according to the Poisson process, and services provided at the servers according to the exponential distribution, and as servers are there. For example, some programs are coming to be processed at the servers, and they are coming according to the Poisson process, and they are processed at the servers according to exponential distribution. and S servers are there. So we know that already that lambda n is lambda, n is 0, 1, 2, and so on, and mu n is n mu, n is 1 to s, and this is s mu when n is s plus 1, s plus 2, and so on. This already we have derived. So therefore this u reduces to, so you know that this will be something 1 plus lambda naught by mu 1 lambda by mu plus lambda naught lambda 1 upon mu 1 mu 2. So and in this fashion, this value in the last is equivalent to, this will be basically 1 plus lambda naught is lambda upon mu 1 mu plus mu square upon 2 mu square plus so on plus lambda s upon, we will have 1 into 2 into s mu raised to power s. In the last we will have mu something mu lambda s plus 1 upon 1 into 2 into s, then mu uh, s plus 1 and so on, like that. Okay, after that this will be basically remain up to s mu raised to power s plus 1. So after that this will become s, one more s will be there. Okay, so that will s into s mu raised to power s plus 1 and so on. So therefore this will basically converge towards uh, equivalent to saying that if lambda n upon s mu raised to power n summation n is from 1 to infinity is converge. This will converge because this will be another value will be lambda. We can write down this here separately, that this will be lambda. Okay, so therefore this will be lambda upon 1 lambda upon s mu plus lambda square by s mu. So this is finite already, and something common we will take here. We are remaining with this quantity. So therefore that quantity if we show is converges, then this summation will converge. So therefore we will get that this is equivalent to showing that S converges if this summation converges. So this converge if lambda upon S mu is less than 1. So therefore this is the condition, lambda should be less than S mu for MMS queuing system. Let us take another example, linear growth model with immigration. So we will have, we know that if n person in the population, then each can give birth with rate lambda, and there is a exponential increase in the population due to external factors such as immigration. That parameter is theta for n is 0, 1, 2, and so on. And each person can also die with rate exponential rate mu. So mu n is n mu. So therefore, in the same fashion, this reduces to u reduces to, because this will be 1 plus c1 lambda naught by lambda 1. Okay, so this will be S converges. That means 1 plus lambda naught lambda naught is our theta upon mu1 mu plus lambda naught lambda 1 theta plus lambda upon two lambda your mu1 mu2 2 factorial mu square plus so on. So that means this reduces to, if we show that summation n is from 1 to infinity, this term we can forget because this is finite already. Theta theta plus lambda so on to theta plus n minus 1 lambda upon n factorial mu raised to power n converges. If this converges, then that means our this S converges. Then let us say this value is, let us say, some n. Let so use ratio test. So limit as n goes to infinity tn plus 1 upon tn. If this is less than 1, then this series converges. So therefore this is equivalent to saying that limit as n goes to infinity theta theta plus lambda theta plus n lambda, that is upon n plus 1 factorial mu raised to power n plus 1, because this is tn plus 1 into, in the denominator we have tn theta theta plus lambda theta plus n minus 1 lambda n factorial mu n. This should converge, this should be less than 1, sorry, this should be less than 1, then this converges. This is limit as n goes to infinity. So we are left with theta plus n lambda upon n plus 1 mu is less than 1. So this n, you divide theta by n plus lambda divided by n upon 1 plus 1 upon n mu. So therefore this is take n goes to infinity lambda upon mu, this is less than 1, so which implies that lambda is less than mu. That means the linear growth model with immigration, the steady state solution exists or the limiting probability exists if lambda is less than mu. So that is the answer for that. So any question till now? Okay, now so same analysis in some books is given by using the generator also. So analysis that will take using generator, which is also known as the infinitesimal matrix. So generator is defined as, because the parameters are Vi and Qij for the continuous time Markov chain and Pij. So continuous time Markov chain, Vi is the rate at which the process make a transition when in state I, and Pij is the probability that this transition is into state J. Qij is the rate when in state I at which the rate make a transition into state J. So Vi and Qij and Pij are the parameter of the continuous time Markov chain. Okay, so Vi we can also denote by Qi also, just a notation. Okay. Both are same basically. So Qij is also there where I is not equal to j, but we may denote this as equal to minus Qi when I is equal to j, and Qij when I is not equal to j. Okay, so therefore this can be written as Q00. This is minus Q naught. This basically minus V naught. Q01, so on. Q10 minus Q1, and so on. Qn0, Qn1, so on. Okay, so this is the basically matrix of Qij rates. These are the matrix of rates basically. And also we know that summation of Qij is summation over j is Vi, this thing. Okay, so we know that summation Qij is Vi, so over j. So we know that summation Qij over j is Qi is nothing but Vi. But here I is not equal to j. Okay, so here our basically your I is not equal to j. That is also the thing. So uh, that means our Q in a row, this is nothing but Qi. So therefore, this is sum Q01, Q00 plus Q01 plus so on. That means summation over j Qi. Okay, and okay, minus Qi is 0. So j is basically, okay, that means this summation is 0. That means sum in row of generator is 0. Sum in row in generator is 0. That is the meaning. Okay, so sum in sum in row in any particular row in a generator is 0. That is the thing. Okay, now we know that our limit h by the lemma star, we know that 1 minus PIIH upon H as H goes to 0 is QI or VI basically by the lemma star, and also limit as H goes to 0 Pij H upon H is Qij. I is not equal to J. Okay, so using these two, we can easily write down that limit. So this can be also be written as, this quantity can also be written as limit H goes to 0 P IIH minus 1 upon H is minus QI, which is nothing but QII, nothing but QII. Okay, so therefore, in totality, we can write down limit as H goes to 0 PH minus I, where I is the 1 0 0 0 0 1 0 so on 0 0 0 1, this matrix, okay, upon H is Q. Okay, so from here we can easily see that if we take a matrix PH where elements PH is basically Pij H, matrix of this varying I and J, PT is this. Okay, so this is the matrix of this. So from here PH minus I upon H is Q is equal to the generator. Also using Chapman-Kolmogorov equations in the matrix form, this can be written as PT plus S is equal to PT PS. So from here we can easily see that this from the Chapman-Kolmogorov equations, if we can make a matrix of Pij, then P plus S is equal to PT PS. So this is the Chapman-Kolmogorov equations. Now, we have P T plus H minus PT upon H is nothing but PT plus H is PT by the Chapman-Kolmogorov equations. This will be PT into PH. Therefore, this will be PH minus I upon H. So therefore, this can be written as PH minus I upon H into PT. Now taking limit as H goes to 0. So therefore, from this equation, we will get P prime T is equal to, this is, if we take the limit, this will go to Q. So this will be PT, Q and QPT. If we take to one side, if we take to other side. So this is nothing but the one is known as the forward equation, Kolmogorov forward equation. Other is the Kolmogorov backward equation. So these are the notation in terms of matrix. So this implies that solution will be PT is P0 e raised to power QT. Okay, but we know that P0 is I. Initial condition is this, because if it is in state P0, 0, 0, 0, that will be 1, P0, 1, 0 will be 0. So therefore this become indicator. So this implies that Pt is e raised to power Qt, which is nothing but summation n is greater than equal to 0, q raised to power n, t raised to power n upon n factorial, which is nothing but I plus summation n is from 1 to infinity, q raised to power n, t raised to power n upon n factorial. So now these are the solution for Pt. So now how to see the, let us take the derivative of this dn upon dtn Pt, which is taking the derivative here, taking the derivative here. So we will get, first derivative will be e raised to power qt into q. So therefore that is pt q. Similarly, second derivative is pt q square. So therefore this will be pt or q raised to power n pt. So when t is equal to 0, this is q raised to power n. Okay, so this was about analysis using computers, because detailed analysis we have already done. So just using matrix, also we can do the analysis using generator also, which is also known as the infinitesimal matrix. So take an example. So consider a Markov chain xt having states 0 and 1 and having generator q, which is minus alpha alpha beta minus beta. This is 0 1 0 1. Okay, so here q01 is alpha, q10 is beta. Okay, so you can clearly see that here V0 is alpha, which is also Q0. V1 is beta. Q10 is alpha. Q Q01 is alpha, and Q10 is beta. So therefore P01 is 1, P10 is 1. So these are the values you can see in the normal when we have done without using generator. So our aim is to find out what is value of Pt and what is the limiting probabilities using that. Okay. So also your, you can also find out the limiting probabilities using because our using this pi q is equal to, if we have to find the limiting probabilities, then pi q is equal to 0 we can use, because that we will get from the forward equation. As t goes to infinity, p prime t goes to 0, so pi q is equal to 0, because that is the answer. So limiting probabilities in that fashion you can find out also. In the case of generator, you can write down in that fashion also. So in the case of generator, this will be pi q is 0, where summation pi j is 1. Okay, so that also you can use for the case of okay, I think so we can now start from next time. We will solve this example and some more solution. So any question till now?